Welcome back, PC World fans, with another major title getting the DLSS love. This time it takes place in the Wild Wild West with Red Dead Redemption 2. The game burst onto the PC scene all the way back in late 2019 with some of the most breathtaking visuals seen in an open world game. By today's standards, Rockstar's Rage engine continues to be not just a gorgeous display of next-gen API power, but also a high-end system's worst nightmare when you crank the settings. But with DLSS, things could change drastically for NVIDIA RTX series owners. Now in this video, I'm going to break things down and see how well it performs and deconstruct the visual differences, talk about what didn't go right, and show you how you can fix it to get the best combination of performance and visuals. But before I get into the specifics of the DLSS implementation in Red Dead Redemption 2, I wanted to take a moment and give a quick refresher on what DLSS is to those who may not follow the tech so closely. DLSS was introduced with NVIDIA's RTX 20 series and is an acronym for Deep Learning Super Sampling, which takes advantage of their hardware-based AI tensor cores. In real time, this hardware takes a lower internal resolution image from the game and uses a machine learning through super high resolution assets from the game to reconstruct the final image as close to native as possible. It does this by combining motion vectors, temporal data, and machine learning. With the latest DLSS 2.0 Plus, the results range from decent to stunning, and a lot of it comes down to the developer and how they implement the tech. And that's what we should talk about with Red Dead Redemption 2's DLSS implementation, where the problem arises. You see, the first wave of people to test Red Dead Redemption 2's DLSS final image were not impressed, and rightfully so. If you were to load up the game in DX12, because Vulkan is a bit of a mess in my experience, and crank the details while enabling DLSS, you'll likely notice some issues. Issues like things being a bit blurry in the distance, assets not rendering properly on light poles and power lines, lots of, ghosting on those power lines, as well as one of the biggest issues being the missing shadow elements. Right away, people got a really bad taste in their mouth, which is unfortunate, because the performance gains are quite nice. Now let's talk about what went wrong and how to fix it. DLSS by nature is temporal. It takes data from multiple frames to finish out an image. Temporal anti-aliasing is, by default, disabled whenever you enable DLSS, as DLSS replaces TAA as the anti-aliasing method used. But what gets left on is TAA sharpening, and that causes an algorithm to get a bit wonky, which results in the issues that people have been pointing out. Disable TAA sharpening and you'll instantly see a much more crisp image with almost all of those artifacts removed. To do this, you'll need to unlock the locked settings, scroll down to TAA sharpening, and slide the bar all the way to the left. That is the best way to set up because there's no reason to add temporal instability to the image. With that out of the way, let's get into the image quality comparisons. To demonstrate this, I used an AverMedia LiveGamer 4K capture card in my workstation machine to capture a 4K output from the gaming rig running a Founders Edition RTX 3080. In each example, I ran the game at a maximum detail settings, but with the aforementioned TAA sharpening filter disabled for the DLSS results. Now the part of the game that we'll be looking at is actually the last section from the built-in benchmark utility where the game runs a like-for-like section of the game. I'm doing this in a way so that we can get to see this one in motion, as I believe it gives a better look at the experience you'll get when playing the game. And I'll leave you for a moment to see for yourselves if you can tell the difference between how things change as we move down the list of DLSS quality options. And then we'll move on to the performance impact. Now, from a visual standpoint, with the fix applied, you'll see the game responded very well. But what does that matter if there's no performance increase along with it? In order to show this, I took a look at the same scene from two different angles, both running the game at maximum settings. The first is from an RTX 3060 running at 1440p, and I found that going from native to quality netted me a respectable 20% performance jump with practically the identical image quality. When I set things to performance, we only go up to 33% in performance, but the image quality hit is noticeable at this level. Quality got us over the 60 FPS hump, so I'd stick with that with this level of GPU for a good mix of image quality and performance. Now, if you're cruising on a super high-end RTX 3080, you can expect to break the 100 FPS barrier at 1440p, but this card has already handled the game nicely at that resolution. So 4K is the focus I wanted to have here. At native settings, the RTX 3080 is able to skirt that 60 FPS line, but quality DLSS is applied and really smooth things out thanks to a 21% performance bump at 4K. At 4K, I would feel comfortable moving down to the balance setting and enjoy a further increase of 29% over native, but at that point you are going to start to notice some of the artifacts around those power lines and trees a bit more. If that doesn't bother you, then feel free to give performance a try, but I'd urge you to give ultra performance a pass unless you're on a 5K or greater panel. Now, with some hiccups along the way, we were able to see that DLSS is a nice option to have for such a demanding game. RTX owners who wish to take advantage of DLSS in quality mode will get a nice bump up in performance, and even more if you're okay with going to balanced or lower for the settings. But Rockstar should certainly fix the TAA sharpening problem with an update to the game, as it's confusing and could hurt people's experience. For me, I'll personally be sticking to the quality setting as I always do, but I'd love to hear your experience with DLSS and what you prefer. Now, thanks for joining me in this look at Red Dead Redemption 2. Hit the like button if you enjoyed it, and make sure you're subscribed to PC World for more PC hardware and gaming goodness.